All right, question number 13. Sean places 28 tomato plants in rows. All rows contain the same number of plants. There are between 5 and 12 plants in each row. How many plants are in each row? Well, first we want to list the factors of 28, or find the factors of 28. So we've got 1 times 28, 2 times 14, and 4 times 7. So if we made that into an actual list of factors, we've got 1, 2, 4, 7, 14, and 28. Okay? So if we do 1 times 28, that's one row with 28 plants in each row. So it would look like this if you planted them. 2 times 14, that's 2 rows, 1, 2, with 14 plants in each row. 4 times 7, that's 4 rows with 7 plants in each row. Those are the only combinations that he can make using these factors. So the only requirement is that there are between 5 and 12 plants in each row. So let's look at this row. Are there 5 to 12 plants in this row? No, that's too many. There's 28. Let's look at this option. We've got 2 rows and we have 14 plants in each row. So that's too much because we're looking for 5 to 12 plants. So let's look at this last one. We've got 4 rows with 7 plants. Does 7 fall between 5 and 12? Yes. So our answer is 7 plants in each row. All right, number 14. Number 14 says, Ella bought some keychains and spent a total of $24. Each keychain cost the same whole dollar amount. She bought between 7 and 11 keychains. How many keychains did Ella buy? So we're trying to understand how many keychains she bought if she spent $24, but we don't know the price of each keychain. All they tell us is that she bought somewhere between 7 and 11 keychains. So we have to figure out how many did she buy. So if we know that she bought $24 worth, let's list out the factors of 24. I listed them here, 1, 2, 3, 4, 6, 8, 12, and 24. I also listed them like this because it's easier for me to visualize. So we've got 1 times 24 equals 24, 2 times 12 equals 24, 3 times 8 equals 24, and 4 times 6 equals 24. So if she spent $24, that means that she could have bought 24 keychains at $1 each to end up spending $24. But we know that she bought between 7 and 11 keychains. So this isn't going to work because the only options here are buying 24 keychains at $1 a piece or buying 1 keychain at $24 a piece. Okay, number 2. She could have bought, or not number 2, but let's try with the factor 2. So 2 times 12 is 24. So she could have purchased 12 keychains at $2 a piece. Does that work for this? She bought between 7 and 11 keychains. She'd have to buy 12 keychains at $2 a piece to equal $24. That doesn't work. Or she could have bought 2 keychains at $12 a piece, but that doesn't work either because it said she bought between 7 and 11 keychains, so we're going to cross this out. Okay, let's try our next one. 3 times 8. So there's 2 ways that she could have gotten $24 as her total. She could have bought 3 keychains at $8 a piece, but that doesn't work because we know she bought between 7 and 11 keychains. Okay, so maybe she bought 8 keychains at $3 a piece. Does that work? If she bought between 7 and 11 keychains, could she have purchased 8 keychains at $3 a piece? Yes. So let's just double check that this one isn't going to work here. So she could have bought, for 4 times 6, which equals 24, she could have purchased 4 keychains at $6 a piece to get $24. But it says she purchases between 7 and 11 keychains, so we know this isn't going to work for her to purchase 4 at $6 a piece. We could also try 6 keychains at $4 a piece. So if she bought 6 keychains that each cost $4, that would equal $24. But once again, it doesn't work because she purchased between 7 and 11, and 6 falls below that. So we know that 4 times 6 is not going to work. 3 times 8 is our only option. And we know that she purchased 8 and they were $3 a piece because it said that she bought between 7 and 11 keychains. So 8 keychains at $3 each. And if we multiplied 8 times $3, we would get our original $24. All right, number 15. Number 15 says, Sandy, aka Trevor's dog, has 16 roses, 8 daisies, and 32 tulips. She wants to arrange all the flowers in bouquets. Each bouquet has the same number of flowers and the same type of flower. What is the greatest number of flowers that could be in each bouquet? So what you do here, this has to do with the greatest common factor. So all I'm going to do is list the factors of these numbers. So I'm going to start with 16. The factors are 1, 2, 4, and 8, and 16. Okay, this is our starting number. I'll put a box around this so it doesn't get confusing. Okay, so 1 times 16 is 16, 2 times 8 is 16, and 4 times 4 is 16. Okay, now we've got the daisies. All right, we got to list the factors of 8, which are 1, 2, 4, and 8. Okay, and we're going to list the factors of 32, which are 1, 2, 4, 8, 16, and 32. Because 1 times 32 is 32, 2 times 16 is 32, and 8 times 4 is 32. Okay, now all we have to do is find the greatest common factor. So common factors are the ones they all have the same. So we can see that they all have 1, they all have 2, they all have 4, they all have 8. 2 of them have 16 and 1 of them has 32. So out of the ones they have in common, which one is the greatest one? Well, that's going to be 8. 8 is the biggest number that they all have in common. So that means that they can put 8 of each flower into each bouquet. All right, let's take a look at number 16. Number 16 says, Amir arranged 9 photos on a bulletin board. He put the photos in rows. Each row contains the same number of photos. How many photos could be in each row? So we're just looking for different possibilities, different combinations, and ways that he can put the photos. So Amir starts off with 9 photos here. And they want to know how many ways can he arrange them, and how many are in each row if they each need to have the same number of photos in each row. So you're going to list the factors of 9. He starts with 9 photos. Let's list the factors. The factors of 9 are 1, 3, and 9, because 1 times 9 is 9, and 3 times 3 is 9. So that's why I made the little curve there, 3 times 3. Okay, so this tells us different ways we can arrange the photos. We could do 1 row of 9 photos. So that's what we did here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 row of 9. We can also do 3 times 3 equals 9. So we can do 3 rows of 3. 9 times 1 is also 9. So we could do 9 rows of 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 rows, and they just have 1 photo in each row. So the answer to the question is, how many photos could be in each row? Well, let's look here. Here in this row, we can have 1 row of 9. We could have 3 rows of 3, or we could have 9 rows of 1. So the answer is 1, 3, or 9 photos.